company has focused on developing solutions for construction and infrastructure. Our philosophy is to, in comparison to other presentations before, I mean, we are a hardware-based company, develop also software to provide the data to the customer. But mainly we do a lot of research in developing very innovative sensors that are difficult to find in the market. So we implement IoT solutions, we implement software, gateways, and on top of that also the platform and cloud solutions. Our main strengths are, let's say, smart sensors. So that's for we have already some patents because some physical phenomena you need to really go very deep in detail and be very innovative and creative. This is why we have many projects with universities here in Spain and outside. Radio communications, because at the end we want to send something and get the data and transmit in different environments. Infrastructures are not very nice, somehow very welcome environment that we can communicate everywhere, anywhere. We need to communicate sometimes, get signals with a passive sensor from underground, or in the concrete. When the concrete is pouring, you pour the concrete, there's a lot of water. Everybody knows that radio waves doesn't communicate in water. So we try to get the signal out of that environment. In some sensors, we play around with wire transmitting not only information but with power, and integrate the systems into a platform, integrate everything to provide the global solutions to the customer. So from the sensor to the data. Maybe someone will then work on the data to optimize, but we need to show the data to the customer. Sorry, I have only 2 slides in Spanish. This is one of them. But the concrete is the second element most used in worldwide. So the first is water, the second is concrete. Concrete really it needs to integrate it into this digitalization in construction 4.0, what is known now. And our aim is to improve in efficiency, security, and cost for the company. So introducing sensors, for example, corrosion, it's it's one of the most critical problems in infrastructures nowadays. Because it costs a lot of losses worldwide. It's computed like 2.5 billion euros of cost losses for corrosion problems. Let's say a bridge gets corroded, it can go down. Something that buildings, a lot of constructions can be really have this problem. This is concrete. When you make a building, you need to pour the concrete, and the concrete starts to get some strength. So what we do is we monitor this strength instead of doing it in the laboratory by breaking specimens. What we do is we integrate some sensors, we locate it in special parts, and then we are monitoring what is the strength of the concrete. And here we can improve, as I will show you later, the efficiency of construction, the time and the cost very fast, like 20–30% in some cases. For falling rocks in the mountain, also there is a lot of causes due to in roads, in highways, in train. What can cause the rock in the road, and for digging trenches in the street or in the field, there is also a high cost of losses, and UK has these putting values of 9,000 million euros per year. That's the causes not only for damages, but also for prospections, how much time you close one road, what you have to the pedestrians, you avoid them to go through that. So all the nuisances for the citizens, etc. And for that, I would like to start first with corrosion. This is, to understand a little bit, I guess you already know, but because everyone has seen what is a construction without the concrete that it's already falling down. Why? Because there is a current flowing through the metal. The metal is the one that gives you really the biggest strength of the building on the structure. So the civil engineering makes calculations, they make simulations, whatever, and they put some metal rivers, and then you pour the concrete, and you expect that there is a resistance of that building for many years. But what it happens sometimes that there is some cracks, you are close to the sea, you have salt, there is lorries in the bridge that are damaging a little bit, micro damages in the concrete, and there is a penetration of some agents that what can cause is that a current flowing through the electrical parts of the structure. What happens with this current? That it starts to oxidize. When there is an oxide here, it happens two things. That one is that you crack the concrete, it can break, and the other one is that the thickness of the metal decreases. So instead of having like 20 millimeters thickness river, or 30, 35, depending on the calculations, then this goes down, and then it can be some dangerous for people next to the buildings or next to the infrastructure. So what do? We measure in a way that until now nobody has done it, because we integrate the sensors inside the structures, and with that sensors, what we do is, if it's a new structure, it's very good because we have some elements, sensory elements, that can be tied to the river, and then you pour the concrete, you get the cables, this is cable solution, so we put the cables outside, and we start monitoring the currents inside from the first minute of the structure, of the building of the structure. We have several type of different, we call it electrodes, so they measure different things, the different parameters. All of them are passive because they must last all the way of the life of the structure. This is the physical meaning of this. I mean, I will not we publish many papers because in this case, but the idea is that okay, can we start measuring what is the penetration of the agents that contaminate the river, and also when there is a current here, we also calculate what is the corrosion in the river. So we have two sensors. One is to detect when it starts already the agents to penetrate the concrete, and another one when it's already in the metal river. Okay. This is our solution started more than 10 years ago with some PhD thesis. Then we developed the first prototypes together with CSIC, is the Center of Research of Spain. And then we implemented already some pilots. This is some pilots in different areas. I can show to you, for example, this is a bridge where it makes a lot of sense, but there is a new bridge. So the people ask, okay, where can we put the sensors? How can we monitor not only where in the place that the trucks, the lorries will go, the cars will go through, but also the pillars. This will be underwater, so can we measure underwater? And then we start working together with the architects, civil engineering, to place the different sensors, to locate them. And if it's a new structure, it's very easy. I mean, for us, it's easy to go there and feel one day we can already install many sensors. If it's a structure that has been already damaged, we can go there and do we can install it, but it takes more effort, but we need to create the sensor inside. So we need to have access to make some drills and then have some contacts, put the cables outside, the data logger, and then we have the data already. Then we show them to the platform. Okay, this is a dashboard that we use. Yes. Yes, yes. There is some electrode, the sensor is inside the concrete. We put cables outside, and we have a data logger. There is a small electronic that is doing the measurements in every different point. But in this case, everything is wired, so we sometimes reuse wired communications in the bridge, for example, or we create a new wiring system, because then we need to collect all the data from wires to a central station that sends to the cloud. But the sensor inside is passive, so it's a kind of electrodes that we make, and those are no battery and will last as long as the structure. What we need to do maintenance is from outside. The data logger, we need to do maintenance from that.
But trying to make that about I mean, it has the life duration.
If
corrodes itself.
Yes, this is what we do. Then is we measure the speed of corrosion, the current of corrosion, some parameters that nowadays are quite difficult to do, because what people do is do manual inspections, go there to measure the corrosion, at voltage corrosion or the potential, and then go back to the company after half a year, 1 year later. What we do is we measure 1 watts per day, so we can see the speed of corrosion, how does this speed progress, and then we can do a warning. So okay, in some installations, in some points, it's better to put to make some maintenance because it's better to enlarge the lifetime of the, let's say, a bridge. Maybe.
Much more of the lifetime of the capture itself.
It will end. It's the same material as the river of the structure. So our capture, our sensor is made with the same material as the river. But it's very new. So if there is a river of metal with some alliation or some aluminum, whatever, we do the same. So if the corrosion happens at some rate in infrastructure, our sensor will correct as well. What we have to do is that we need to introduce we have patented the way to introduce the current pulses and to do them in order to have, not to affect the currents inside, because if you inject some current, you can affect the way it corrects the speed of corrosion. So we need to inject a pulse to do the measurement and not to affect the system itself. This is our, main idea. Our sensor will correct as well.
What's the life duration that you guarantee to clients?
If the bridge, for example, lasts 30 years, our sensor will last 30 years. 15 years, the important thing is that the corrosion or erosion of our sensor will be exactly the same as different structures, as our structure. What we need to do maintenance is the electronics, which is outside, because some systems are power, solar battery power, batteries, and then we need to maintain that. But the sensor itself, if there is a corrosion of, for example, loss of thickness of 3 millimeters, our sensor will degrade the same. But it will work. Why? Because the way to measure, we do 1 measurement per day, we send some pulses, multimetry pulse measurements, we do the measurement, we sleep, another day, next measurement.
To be sure that I have understood that your sensor is made of the same material that the structure, so you corrode and you measure your sensor, the corrosion of your sensor.
Yeah. So if there is no corrosion, our sensor will not corrode and we will measure nothing. And then if there is some corrosion, we can start measuring, and the speed of corrosion. What is the micrometers that we lost per year, for example? This is very important because the people can already foresee what is the reparation that they need and say, okay, in 3 years, maybe I go, here, maybe this is more indicative. There is the lifetime of the sensor, and maybe you can still spend 10 years without any corrosion at all. And then there is an initialization phase, what is called initialization phase, that we have a loss of thickness. This is the loss of thickness that can correlate as well with the currents that start flowing through the structure. And if there is a point that these currents really start going high very fast, we need to inform that, and this is the critical part. And then it's better to repair it, to fix it, and then you can enlarge the life of the structure for many years. So the important part is to be able to measure this initialization and propagation of the. Okay, then we put this into a dashboard as well. We send every 3 months automatic reports to our customers, so they can know what is if there is an incident. For example, if there is a solar power sensors, gateways that take the data. So what is the functionality? If there is any, for example, shadow for Castellat for 1 month, 1 year, 1 week, sorry, we can measure. And then all the data related to the corrosion. So we measure resistivity of the concrete. We measure loss of thickness in micrometers. We measure potential of corrosion. This is the standard way to do it nowadays, measuring the potential of corrosion, temperature, and different parameters that you can correlate and get your results. of course, well, we have been already implemented these in different real use cases. Highways between Madrid and Barcelona, on the ocean for mussels, growing platforms, in the pier in Balearic, well, in different places. This is, we are starting, we passed the pilot, now we are already selling this, so we are now growing a little bit in more demands to install these sensors, because this has been already validated, I will show later, with the main companies in Spain. And okay, for corrosion, that's it. Maybe I will go only 1 minute. I go really fast, maybe. 2 minutes. Okay. Thank you. I will go through that very fast because I have also many slides, but just for you to have an idea. Train chip is, what we do is we put a chip on the pipes underground. Okay, this is passive. It's like RFID. We optimize the antenna design to get the signal very deep. So and then what happens? We can digitalize the underground structures because we can detect not only what you can find underground, but also all the information related to the utilities, gas, water pipes, electricity pipes, fiber optics, etc. The same, we put this into a platform, and on top of that also we create the virtual reality image. Once you detect, for example, in this main hall, you can put a train chip, and from here it can be, you have a 3D image, you can have the starting point, what is the intersections, different type of pipes for electricity, water, whatever. So we digitalize somehow something that people doesn't see normally. And one sec is the other one that we put in the structure, when you make a new building, we put this in the river and we monitor the strength. So what we do is, instead of breaking the specimens, the constructor normally, they give these specimens into the lab, they break it, they say, okay, I have like 25 kilonewtons of resistance. What we do is we monitor minute by minute the resistance of every floor made with concrete. And this is totally wireless, so this is sensor. It will last 3 months, and after 3 months, it just the battery goes down. Also the platform, and Rockship is the last one. It's just for we put sensors to detect falling rocks that can fall down into the road. So we have different type of solutions for that, different type of sensors. At the end, we get the data of all the sensors, and our idea is to see if there is any of these anchors that has broken. Sometimes there is a movement. We locate this in the special places that there is some danger, some stone that it's going to fall down. And what we do is to monitor all these possible dangers in order to avoid accidents in the road, and in the train, etc., etc. This is some of the pilots that we have already implemented, but as I said, from pilots now we go already to customers, and we already have some customers, and people so far have a good feedback from those sensors. Okay, thank you, and sorry for the extra 2 minutes.
If you have any question, 1 or 2 questions, we have time now.